Our next problem here asks us, how do we verify the trig identity cosecant x cos squared x plus sin x equals to cosecant of x? So this is actually a verification problem, and when someone asks you to verify something, you actually start at the left side of the equation. So in this case, we'll start with cosecant of x cos squared x plus sin x, and we're trying to simplify the left side of the equation to try to get this side of the equation to equal to the right side of the equation. So we're basically trying to get this side of the equation to equal to cosecant of x in the end. And this is how we verify this identity. Of course, if you want, you could start at the right-hand side and try to get to the left-hand side, but it's much more difficult, in my opinion, to do it the other way around. At least, or in this case, it is. But maybe if this question is written as verifying cosecant of x equals to cosecant of x cos squared x plus sin x, in that case, verifying it the other way around is much easier. So you can have a scrap paper and then just do some rough calculations of verifying it the other way around, and then try to write down the proper answer, going from the bottom step to the top step, so going the other way around. That would also work. All right. So yeah, let's just try to verify this. So we're basically just trying to simplify this. So in this case, we know sin of x is pretty much as simple as it gets. We probably don't need to do something with sin x just yet. And cos squared x, again, I can't really see how we would do something about it. But cosecant of x, we can do something about that. So again, just based on the identity we talked about before, we know that, let's write down another color. We know that over sin of x, so we know this can be simplified. So now let's just try to write the cosecant of x as 1 over sin of x in the equation. So now we have cosecant of x equals 1 over sin of x cos squared of x plus sin x. So next, let's just move cos squared x on top of the sin x. So we have the same equation as the following. Now we have a fraction and we have a fraction which is cos squared of x over sin x, and we have another sin x over here. So let's just try to get the fractions to have a common denominator, and then we could probably finish our simplification. So we know that cos squared x over sin x is we're just writing it down as the same thing as the same term as what we had in the previous step. But in order for sin x to have a denominator of sin x, we need to multiply the sin x term by 1, and we need to write this 1 in a special form. We write this 1 using sin x over sin x. This way, the value of sin x hasn't changed, and also we know that sin x over sin x is just 1 because a term over itself is equals to 1, or I guess a number over itself is equal to 1. So yeah, let's just do this here. So we have sin x times sin x over sin x. That would be just multiply the sin x by the top or by the numerator of the fraction, and we have sin squared x over sin x over here. Now, the two fractions in our expression has the same denominator, so we can just add the numerator together. So now we have cos squared x plus sin squared x over sin x as our next step. Now, we know that one of the Pythagorean identities is 1 equals to cos squared x plus sin squared x. So we know that cos squared x plus sin squared x is also equal to 1. And then for the next step, we can just interchange the 1 with the cos squared x plus sin squared x because they have the same value. So the result of our equation wouldn't change. So yeah, we know that cos squared x plus sin squared x collectively over sin x is equals to 1 over sin x. Again, for our first step, we know that 1 over sin x is the same as cosecant of x. So we know here we just have cosecant of x. And we are done of verifying this identity because on the top we started with cosecant of x, cos squared x plus sin x, and we arrived at cosecant of x. So we started on the left side hand side of the equation that we want to verify, and we ended on the right hand side. So we completed our verification, and this expression is true. Perfect. Now let's look at our sample solution over here. Yes, they use the same steps as we did. They didn't write out the steps in as much of the detail as we did, but that's just because I just thought explaining in more detail should help. So yes, that's pretty good. So let's just say the solution is correct. Good job. Yay. The solution is correct.